Okay, now we're going to state features of and graph f at x equals x squared plus x minus 12 over x squared plus 7x plus 12. To start off, we're going to factor the top and the bottom, try and simplify things. So we need numbers that add up to 1 and multiply to negative 12. That's going to be 4 and 3, where 4 is positive. And we need numbers that add up to 7 and multiply to 12. So that's going to be 4 and 3, where they're both positive. Okay, at this point, we can cross out x plus 4 because it appears on both the top and the bottom. Sorry, that was positive. We can cross out x plus 4 because that appears in the numerator and the denominator. However, if we do that, we must explicitly state immediately right beside that x is never equal to negative 4. Because if it was equal to negative 4, this whole function would be completely undefined. So we can go ahead and cross those out now, knowing that x is never negative 4. Also implied here is the restriction that x is never equal to negative 3, because if it was, we'd be dividing by 0. So we have this small set of numbers that x is never equal to. Never negative 4 and never negative 3. So now we have f at x equals x minus 3 over x plus 3. Where x is never equal to negative 4. Now, I have a video going into all of the details of how we find all the features of this graph, and I'd invite you to watch that if you want to know where any of these things come from, but I'm gonna answer this quickly at this point. Our domain is x is never equal to negative 3, x is never equal to negative 4, otherwise it's any real number. Our range is that y is never equal to 1. I know that because if I put in a large value for x, we get close to a large number over itself, which approaches 1. It's never quite equal because we're subtracting and then we're adding, but it gets arbitrarily close to it, so that's going to be an asymptote. So that leads to the asymptotes. And the asymptotes are, we have a vertical asymptote where x is equal to negative 3, and a horizontal asymptote where y is equal to 1. Our x-intercept is going to be the value that makes all of this equal to 0, makes f at x equal to 0. And clearly f at x is 0 when x is equal to 3. So our x-intercept is x equals 3. Our y-intercept, what y value do we get when we put in a 0 for x? When x is 0, we've got a 0 here and here. F at 0, and I'll write that out in Lagrange notation. For our y-intercept, our function evaluated at 0 is 0 minus 3 over 0 plus 3. So our y-intercept is negative 1. And finally, our end behavior. As x approaches infinity, we can tell from looking at our graph and imagine plugging in large values. As x approaches infinity, y approaches 1, but the numerator is always below the denominator. So y approaches 1 from below. And as x approaches negative infinity, y approaches 1 from above. How do we know it's from above? Remember, f at x is equal to x minus 3 over x plus 3 as long as x is never equal to negative 4. So if we put in large negative values, let's say negative 1,000, we get negative 1,003 divided by negative 997. This is a positive number that is approaching 1, but the numerator is always slightly larger than the denominator, so it stays above. That's how I know as x approaches negative infinity, y is approaching 1 from above. And likewise, as x approaches infinity, y approaches 1 from below. You could plug in a couple of large numbers and then you'll see a numerator that's always smaller than the denominator, yet those two numbers are approaching each other as x gets closer to infinity. So now we'll take all this information in and draw a graph. We have our asymptotes at x equals negative 3 and y equals positive 1. And as x gets large, as x goes to infinity, we're approaching 1 from below. So it's going to look like that. And we're approaching 1 from above as x goes to negative infinity. And we have a y-intercept of negative 1. And we have an x-intercept of positive 3. And again, because this is an asymptote, I know that this is getting arbitrarily close to, but we'll never reach that line as we go this way, and also as we go this way. Because on this side, as we approach negative infinity, we're approaching negative infinity from above, not below, it has to be on the positive side here. You could plug in a couple of values to determine that for sure. And the same thing here, as we go to positive infinity, we're approaching positive infinity from below, plus we have a couple of points here, so I know that this asymptote is gonna be negative over here. And you could plug in a couple of points into f at x to verify that with total certainty. Now remember, we had stated earlier that the point x equals negative 4 is undefined. And we indicate that on the graph to going over to the location where x is equal to negative 4. And we draw a circle here, indicating that there's a hole in the curve. It is not continuous at that point.